So let's look at an example here. An ecologist wants to determine if tuna caught in the Atlantic Ocean are different in weight from those caught in the Pacific. So random samples of 100 fish were taken from each population. We had the following sample data. So the 100 from each population, that is telling us that N1 is equal to N2 is equal to 100. And then we saw the mean weight in the first sample from the Atlantic was 145, standard deviation 4. Mean weight in the second sample, 148, standard deviation 7. Constructing 90% confidence interval for the difference in means and interpret the result. So first we want to verify our requirements here. So independent random samples from two populations. These samples, they should not be dependent. You know, we got Atlantic Ocean, Pacific Ocean. I would not think that they're related. Sample sizes greater than 30? Yes, they were both 100. Okay, so both of those check out. So first let's compute our standard deviation of the sampling distribution. We don't know sigma 1 and sigma 2, so we need to use this formula. So we can approximate that with, this will be square root of S1 is 4, S2 is 7. So 4 squared over 100 plus 7 squared over 100. And put that in the calculator, you get approximately 0.806. So then our confidence interval, we take the difference of those two sample means. So this will be 145 minus 148. And then we are going to add or subtract here. Z alpha over 2, this is a 90% confidence interval. So back in chapter 7, we had this table of common confidence coefficients. For 90%, the Z alpha over 2 is 1.645. So this will be 1.645, and then times that approximation to standard deviation, which was our 0.806. And so if you enter this into the calculator, then you will get -3 for the difference, plus or minus, and then this is 1.33 to 2 decimal places. So that is going to be -4.33 to -1.67. So -3 minus the difference, -3 plus the 1.33. So, and then our interpretation here is that we would be 90% confident that the true mean difference, or the population mean difference, is between -4.33 and -1.67. So in other words, that means 90% of the samples are going to contain the true population mean between the upper and lower bounds. So since both of the upper and the lower bounds are negative here, this means that the difference is negative with 90% confidence. So mu1 minus mu2 is going to be less than 0 with 90% confidence. So that means, bring this over on the right-hand side, the mean in the Atlantic is less than the mean in the Pacific with 90% confidence. So that's confidence interval. And then we can check this on the calculator, the TI, doing stat test 2 sample, let's see, that's 2 sample Z test. We can do 2 sample Z interval. So we go to the calculator here, stat tests, and then we want 2 sample Z interval right there, number 9. And we have summary statistics, so we're going to arrow over here and highlight that. And then our sigma 1, we have 4, sigma 2, 7. We're using S1 and S2. X1 bar, that was our 145. N1, 100. X2 bar, 148. N2, 100. Confidence, 0.90. And, whoops. And calculate. And there's our negative 4.33 to negative 1.67.